So, the problem in this PCB is that it turns on and the beep sound also comes from it, but its display is not working, and it is not performing any function at all. When the display itself is not working, then none of its functions will work either. This is a transformer-based PCB, and it belongs to a non-inverter AC. Now, if we physically inspect it, this side also looks dirty, and along with that, one of the capacitors seems to have some issue. As you can see, it has even come out or become faulty, which is located near the ULN 2003. So let's check it from the other side. Here is the capacitor. This means that the capacitor has blasted here, and because of this issue could be happening. Now before changing the capacitor here, I will check the voltage on this voltage regulator. This is a 7805 and a 5-volt voltage regulator. Now I supplied electricity to the system, and as you can see, the beep sound has already changed, but the display is still not turning on, and the remote is also not working. So I will check whether the voltages are coming properly or not. The center pin is ground, and we will place one side here. So as you can see, proper 5 volts are coming here, which means it is fine. Now let's also check the input voltage. So here, 14.25 volts are coming, which is also fine. This means that the entire circuit here is working properly, and the issue is only on the low side. So now I will replace this capacitor. I am going to install this ceramic capacitor. This is a non-polarized 100 nanofarad capacitor, so I will install it here. Now I will turn it on. It is turned on now. Let me check it with the remote. Someone has removed its on-off switch. So it is not turning on with the remote. This means that its display is still not working properly. The on-off switch that is normally installed has been removed by someone, and someone has already worked on this PCB before, so let's check it. Now I will open it and take it out. As you can clearly see, someone has removed the switch here. You can see that work has already been done here. So for now, I will temporarily supply electricity to it. I have supplied electricity, and now we will connect these 2 points together. So it is turned on now. Look, the display has appeared. The points are showing here, and the green light has also turned on. The green light turned on and then turned off because my hand is touching the back side, which is causing it to switch off. Look, now it has started showing an error. The E6 error has appeared. So the E6 error in a simple AC is related to the fan motor. Right now it is unable to detect the fan motor, which is why this error is appearing. One fault in this PCB right now is that electricity is reaching its input, but it has still not turned on this relay at the output. That is one fault in it. The second fault is that its remote is not working with it. Now let's test it. I have connected the power, and now I'm turning it on. As you can see, the display is now working perfectly, and the on-off function is also working properly. Now, there are only 2 issues remaining. One is that the relay is not working, and the second is that the remote is not working. So, I'll turn the power off first. The power is now off. Now the solution here is very simple and easy. The small capacitor that became faulty is connected to this ULN 2003 Darlington Relay Driver IC. If this IC does not work properly, then what will happen is that the relays connected here will also not operate correctly. As you can see here, there are relays installed on the board. One relay is for the fan, and the other is for the reverse valve. There are 2 relays installed here because this is a heat and cool system, I think. The fan is also directly controlled from here, and the heat and cool system is also controlled through these relays. And this relay setup is basically used to start the compressor. So, first of all, we will fix the remote issue because the remote functioning properly is also very important. But before that, we are going to replace this ULN 2003 IC first, and then we'll see what happens next. This circuit will not work properly anyway. So, this is the ULN2003LIC. Now, I'll connect the power and turn it on. Let's wait for a little while. The display has started showing 23 degrees, and it is still showing the E6 error because the motor is not giving feedback to it. So now let's fix it. Now I'll turn it on. I turned it on, and earlier it was showing an error. So once again, I'm turning it on. Now I'll wait for a little while, because this is a simple AC, and it will take around 3 to 4 minutes, then it will turn this relay on. So the relay has turned on, which means it has turned the compressor on. You can see it is now on. The compressor has started. Now the only thing left is the remote, because the remote with this unit is not working. I'm checking it, but it is still not working. So let's fix the remote as well. As you can see, an RF sensor is installed here. I'll check this sensor to see whether the voltage here is proper or not. The center pin is ground, and I'll check one side pin. So here you can see around 1 volt is coming, and on the other side there should be 5 volts, but it is showing 3.64 volts, so it looks internally shorted. So, for this we will check the voltage on this IR sensor, so we can know whether it is working properly or not. Now I will connect the switch. I turned it on, and it has turned on at 23-degree temperature. Its center pin is ground, and this left side pin is the input voltage, where 5 volts should be coming. And this right side pin is the output pin, so let's check it. So here we are getting 3.645 volts, which is low. There should have been 5 volts here. And let's also check the output. So here we are getting 1.6 volts, which is wrong, because when 5 volts are coming on the input, then the same 5 volts should also appear on the output when it is not performing any function. But when it works, then this pin generates a signal, so that can be in different patterns on the output pin, but the 5 volts remain constant on its input pin. This IR sensor itself can also be short internally, and that can also be the reason, where the difference in peak voltage, etc., can also cause this issue. So now I will check the voltage again. This PCB has turned on. The center is ground. On the left side there is 5 voltage, and on the right side there is output. So we check the 5 volts here. So look here, we are getting 4.98 volts here, and on the output we should not get anything. Look, there is nothing on the output. It is completely fine. Now let's install a new IR sensor in it. Now, I will again check the voltage on the IR sensor. So the voltage is still dropping after connecting it, meaning a short circuit is happening here. Now, I was getting confused here, so I removed the IR sensor from here, and now I will check the voltage here in DC mode. I will place the black probe on ground and the positive probe on positive, so let's check it. At this time, 4.97 volts are coming here, which are completely fine. There should not be any voltage on its output, so let's check it. Before 1 volt was coming, and now 0.815 volts are coming here, which is not correct. There should not be voltage here. Look, now it has gone to 1.54, so there is some issue here, so I will turn the electricity off. Now I will follow its output point. It came from here directly to this side, and it reached pin number 3. This is the pink wire. We will keep following it, and we will reach here on the main PCB. Look, this is pin number 3. On this other side of the PCB, there is resistance R104. Which is connecting one point to another point. And after this ahead, I think this resistance is coming. This is STR120A. Now one thing is completely clear here, that this PCB is very old. All these resistances, look, there's a lot of rust on them, so this is not a good thing. This causes faults in the PCB. Right now the rest of the PCB is working completely fine, but only the remote is not working. So we will check all these resistances. So first of all, I will check this resistance first. This is a 10 kilo ohm 104 resistance. It is showing the correct value completely fine. Now this other resistance, when I was checking it off camera, it was going into mega ohms. Now when I am checking it on camera, look, it is showing approximately 2 kilo ohms. It is slightly low. So this resistance seems faulty to me because its value was going into mega ohms. Now in this PCB, I changed some parts because there was corrosion and rust around the resistors, so I replaced them. But even after that, it still did not get fixed. We are still finding the same short circuit in it. So what I'm going to do now is turn it off. And as you can see here, I will remove it from here. I have removed it now. Now what I have is another display. It is a DC inverter display, and the company is the same. Both are from TCL. The wire combination is also exactly the same. Let me zoom in and show you. So we will try this one. Maybe the problem is in the display itself. Because the voltage is coming correctly and the PCB is also working properly, now I will try this display. So I turned it on, and its display also powered up. Now let's test it with the remote. I turned it off with the remote, then turned it on again with the remote. So the remote section is completely okay now, and it is also receiving the signal properly. And look, whenever I press the remote button, pressed again and again, you can see it is responding perfectly. This means that this display itself has a short circuit, and because of that, the sensor line is also getting shorted and causing problems in the sensor as well. If we normally check it, let me show you here. Whether it is running or turned off, look here. This is the input, this is the ground, and here we are getting 5 volts. As soon as I change this, then look here, we should also get 5 volts at the output for it to work properly. But when the voltage is dropping, for example, here it becomes 3 volts, and here it becomes around 1 point something. So, because of this, the sensor gets shorted, which is why it is not working properly. And as I already showed you, the display itself is causing the short circuit. In this display, I already changed the capacitors and resistors, and now only this IC is left. Either this IC or the display section itself could be causing the short, because even though they may not seem directly linked, the circuit is connected as one complete system, so the fault can affect other sections as well. So now let's replace this IC. This is the display control IC, so first we will change it. Now the display voltages have become proper, and let me show you. I will connect the probe to the ground pin in the center, and here we will check the voltage. For that, first we switch the meter to DC voltage mode. So as you can see here, we are getting 4.96 volts. Now let's also check the output side. There as well we should receive around 5 volts. You can see here, it is 4.91 volts. It drops slightly, but the voltage is basically the same. Now this sensor is working properly. Let me show you by operating it with the remote. Look, it is currently off. Now I will turn it on. You can see, at 16 degrees it has started working, and its fan has also started running. Now I will turn it off again, and it is turned off properly. Now, as I told you at the beginning, its on-off switch was not installed, and at first I thought someone had removed it. But now, it seems like it may have been removed from the factory side, because as soon as this switch is connected here, it causes a short circuit. And due to that short circuit, the sensor stops working properly. So that's why I removed it from here. And anyway, we normally use the remote to operate it, so I have left the switch disconnected. Now everything is working properly. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.